Hello children, today on Fun Learning we're going to learn about fractions. Fractions are parts of a whole, and in a fraction there is usually a division bar or division line, a numerator and a denominator. A numerator is a number on top, while the denominator is a number below. Okay, this is a fraction, this is a numerator, and this is a denominator. Okay, now let's talk about the types of fraction. There are three main types of fraction. Number one, we have the proper fraction. We have the improper fraction. And we have the mixed fraction. In the proper fraction, the numerator is greater than the denominator. You see, the numerator, this one on top, number 1, is lower than the denominator. This one, number 3. This is why I call it a proper fraction. For improper fraction, the numerator, let's take for instance 4, is higher than the denominator. Let's take for instance 3. This is an improper fraction because it's not proper. The numerator is higher than the denominator. Now, let's go to mixed fraction, the third type of fractions. Mixed fraction contains a whole number, a numerator, and a denominator. Proper fractions have a numerator that is less than a denominator. Improper fractions have a numerator that is greater than the denominator, while mixed fractions have a whole number, a numerator, and a denominator. Good. So let's take some examples of fractions in real life. This is called a pizza. This pizza has how many parts? It's divided into how many parts? 1, 2, 3, 4, 5, 6, 7, 8 parts. You see, there are 1, 2, 3, 4, 5, 6, 7, 8 parts in this pizza. Okay, now if you want to get and as you can see, some parts of the pizza are cut. You see, this part is cut, this part is cut, this part is cut, and this part is cut. So you can divide this or state this in a fractional format by saying, let's take for instance, to get the fraction of cut parts to the whole part, let's count the cut parts. 1, 2, 3. So this is the numerator. 3 over, there are 8 parts in this pizza. 1, 2, 3, 4, 5, 6, 7, 8 parts. So it's 3 over 8. Good. Because there are 3 cut parts out of the 8 total parts. So you can see the fraction of cut parts to the whole part is 3 over 8. Good. Now let's try another example. Do you know what this is? This is called a train. Let's count the parts of the train. We have 1, 2, 3, 4, 5, 6 parts of the train. So the total number of parts in this train are 6. Now let's count the total number of blue cats in the train. 1, 2. So you can say the fraction of blue parts to the total number are 2. 2 over 6. That is the fraction of blue cats to the total number of cats available on the train. Good. Now let's count the total number of red parts available on the train. We have 1, 2, 3, 4 parts. So the fraction of red to the total number of parts of the train are 4 over 6. This is called a fraction. 4 over 6 parts are red. Let's try something else. This is a cycle, right? And the cycle is divided into 6 parts. Let's count the parts. 1, 2, 3, 4, 5, 6 parts. So there are 6 parts in this circle. So let's say a part of the circle is shaded. Okay, now 2 parts of this circle are shaded. Can you get a fraction of shaded parts to the whole number, to the complete number of parts? There are 1, 2 parts shaded, so it's 2 over 6 parts shaded. Good. Let's take, for instance, another part is shaded also. We now have 3 shaded parts, so the fraction becomes 3 over 6 parts shaded, because there are 1, 2, 3 shaded parts, and there are 1, 2, 3, 4, 5, 6 total parts. Good. Now let's try another example with a box. You know this shape? This shape is called a box. Now, how many parts are there in this box? Can you count? There are 1, 2, 3, 4 parts in this box. That's 4. Let's take, for instance, one part is shaded. We have 1 part shaded out of the 4 parts of the box. That makes the fraction 1 over 4, because 1 part is shaded. Now if we shade 2 parts, the fraction becomes 2 over 4, because there are 2 parts shaded out of the total number of 4 boxes. Now let's try something different. What if there are 3 parts shaded? If 3 parts of the box are shaded, we have something different now. This was a proper fraction because the numerator was smaller than the denominator. But when 3 parts are shaded, it becomes 3 over 4. It is still a proper fraction, as the numerator is still less than the denominator. Good. This is a proper fraction. Now let's try another example. This is a pentagram. Can you count the sides available in this diagram? There are 1, 2, 3, 4, 5 parts available. So what should I do? I should write 5 as the denominator, because there are 5 parts. Because there are 5 parts, in this diagram. Now, what if one part is shaded? What is the fraction of shaded parts to the whole? It's 1 over 5, because one part is shaded. And if there are two parts shaded, it becomes 2 over 5, because two parts are shaded. The same goes if there are three parts shaded. Can you guess the fraction here? You count the sides that are shaded. 1, 2, 3 parts are shaded. 1, 2, 3 parts are shaded out of 1, 2, 3, 4, 5 sides. So the fraction becomes 1, 2, 3 out of 5 parts are shaded. This is a proper fraction. Good. That's all we have today on fractions. Check our next video to learn how to reduce fractions. Bye.